Hello, my amazing students. We are now starting 1.4, and I'm going to do about every 10th problem so that you have a good sampling of work. And I'm going to turn around and you're going to look over my shoulder like we've been doing, and we will begin. Okay, so here we are with problem number 10. And on 1.4, we're supposed to find the equation of the line in slope-intercept form that has a slope of 2/7 and a y-intercept of 0, -6. So that one's pretty easy. We shouldn't have a problem with that because the slope-intercept form, y is mx plus b. See if I can get a little bit more light on that board. Okay, I'm going to adjust that. Okay, so y is mx plus b is our slope-intercept form, and all we have to do now is just plug in our slope and our y-intercept. So this is about as easy as it comes when you're creating an equation. So our slope is 2/7, and it will go right here where the m was, and our b, or our y-intercept, is going to be our y-intercept here, or -6. So I'm going to erase the positive so it looks nice and clean there, and put a -6, and that will be the equation for number 10. Now I'm going to move on to number 20. Now we're supposed to do the same thing, but we're supposed to do it with 2 points. And remember, when we have 2 points, that we're first going to take those 2 points and find a slope. So we first need our slope formula, which is going to be y2 minus y1 over x2, take away x1. And then when we do it with this one, we can say, okay, 1/2 take away 5. And we can subtract in either direction as long as we're consistent. So now, to be consistent, I'll do 1 take away a -1. Okay, so I've got a 1/2 and a 5. Can I write that 5 instead of a 5? Can I write it as a 10/2 to make that a little bit easier? So 1 take away 10 is -9/2. So I get -9/2 over a 1 plus a 1 is a 2. And then -9/2 divided by 2 again is going to be -9/4. Remember, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So -9/2 times 1/2 is a -1/4. So this is my slope. So then I'm going to take the slope and one other point. So I'm going to use the easiest point, the -1/5, doesn't have a fraction in it, and I'm going to make the equation. So I'm going to do this 2 ways again, because I've taught you both the point-slope form, which you should know, and the slope-intercept form. So we're going to do this problem both ways. So I have room enough here to do the problem using the point-slope form, and then I'll have to get another board to do it the other way. So we're going to have y equals mx plus b, the slope-intercept. I don't know what I said before, but we're going to use the slope-intercept for this one. And so y is, and there's our m, -9/4 x plus b. Okay, now, when we have a point, we don't have a y-intercept, so we're just going to use one of our points in place of the x and the y in the equation, not the b. We're trying to find out what the b is. So we're going to plug in -1 and 5, and so instead of my x right here, I'm going to plug in a -1, and instead of my y right here, I'm going to plug in a 5. Okay, so if you've done it correctly, it should look like that right now. All right, so now we're going to go ahead and clean this up. 5 is equal to +9/4 plus b. Okay, but then I need to get the 9/4 on the other side. So I'm going to turn the 5 into, instead of 5, I'm going to make the 5 20/4, because 20 divided by 4 is 5. And then when I take the 9/4 away, I'm going to get 11/4 equals b. So we're going to put b equals 11/4. So we found our y-intercept. Okay, so now I'm going to just go ahead and erase this because I need a little bit more space on this board. And we've already finished that. Okay, so now here's my b and here's my slope. So we're going to go back into y equals mx plus b, our slope-intercept form of the line, and I'm going to plug in my -9/4 for my slope, and I'm going to plug in my 11/4 for my b. Okay, so now this should be the slope-intercept form of the equation of the line. Now, before we move on, let's check it. Okay, we've got a -1 and a 5. If I put a -1 right here and I multiply these together, then I get a +9/4 plus an 11/4 is a 20/4, which would be a 5. And it works. So always check your equations and make sure they actually give you what they're supposed to. So now I'm going to erase a board and we're going to do the same thing, the same problem, but we're going to use our point slope form. Okay, so here we are with the same information. What I did is I wrote our 2 points at the top of the board. I refigured our slope. Notice that I went the opposite direction this time just to show you that you get the same slope. And now just for fun, we're going to use the other point. So this time we're going to use 1 1/2. But we're going to use our point slope form of the line, which is y minus y1 is m x minus x1. Okay, so we're going to plug in our new point that we're going to use, which is going to be x right here where the x1 is. So we'll plug that in, and the 1/2 right here where the y1 is. And then the m, which was -9/4 right here. Okay, so we're using the different method to show that we get the same equation we did previously. So now we got y minus 1/2 is distributing. We're going to get -9/4 x plus 9/4. Okay, and so then I'm going to add a 1/2. But notice that adding a 1/2 is the same thing as adding a 2/4. So that cancels. So now I get y equals -9/4 x, and then 9/4 plus 2/4 is 11/4. Okay, which is, let me see the board up close. Okay, which is exactly what I had on the other board, which I did not erase. So we had gotten up here on the right, we had gotten -9/4 x plus 11/4. And now on this board, we also, using a different method and even a different point, got the same equation of the line right here. Okay, so that is number 20. Very thoroughly done. So now we're looking at problem 29. I chose 29 because I wanted, I just liked the points better. But we're trying to find a horizontal and vertical line. Remember that our horizontal line is going this way, okay, and it is a y line. Y cuts the y-axis. So horizontal lines are y lines, and vertical lines are x lines. Okay, so when I'm looking at a horizontal line, then it's a y line, so I'm going to take the y coordinate and I'm going to say y equals -1. To take the vertical line, it is an x line, so I'm going to use the x coordinate, which is 2/11. And there you have number 29. Very quickly done. Remember, horizontal lines have a slope of 0, and vertical lines have a slope of undefined. Okay, so now we're moving on to problem 40. So we are given a system and we're trying to determine if this system is parallel, perpendicular, or neither. Okay, so when I look at this, I'm going to say, okay, I can turn each one of these around into their slope-intercept form, or I can remember the little trick I showed you that when you have something in standard form, ax plus, remember ax plus by equals c is standard form. And when you have something in standard form, it is very easy to find its slope if you remember the slope is negative a over b. That will always be your slope if it's in standard form. Now remember, this is my a. So negative a would be negative 2 divided by the b, which is a negative 5. So that one on the top has a 2/5 slope. So that's slope 1. We'll say slope 1. And then slope 2 is going to be negative 2 over positive 5, which is a negative 2/5 slope. Okay, so we found the slopes, and if we are parallel, we have the same slope. So one is positive, one is negative. They are not the same. Whoops, I didn't write that negative very well, did I? Okay, one is positive, one is negative, so they are not the same. So they can't be parallel, but they do not meet the qualification for perpendicular, because remember, perpendicular slope, okay, is negative reciprocal. Okay, so the negative reciprocal of 2/5 would be negative 5/2. But this one is not negative 5/2. So we have a neither situation. This one is neither parallel nor perpendicular. Okay, that was number 40. Okay, so now we're going to do number 46. Parallel to a given line and then perpendicular to the same line through the given point. Okay, so now this line is in standard form. So the slope is going to be negative a over b, which is going to be negative 2 over 1. Okay, so there's my slope of my given line. Now look, if I were to take this line and try to solve it for y, then wouldn't this 2x go over here as a negative 2x? And negative 2 would be the slope, and there it is. Okay, so you can do it either way, but negative a over b is faster. So we got the slope, and we've got the point. So parallel lines have the same slope, right? So the parallel line is going to have a slope of negative 2. The perpendicular line is going to have a negative reciprocal slope. So it's going to be positive 1/2. Okay, so we know our slope for our perpendicular line and our slope for our parallel line. Okay, now remember that once we extract the slope from that line, we don't care anything about that line anymore. It's gone, it's garbage, we don't need it anymore. Okay, what we need is these points and these slopes. So what I'm going to do, since I'm using my board space is very precious here, I'm going to erase this and start to work with these two slopes. And I'm going to go ahead and use, just for the sake of showing you both, I'll use the slope-intercept on the first line. So y is mx plus b. Okay, we're going to replace the m with negative 2. So there's my negative 2. And then I'm going to replace the x value with the negative 4. So there's my x value. And then I'm going to replace the y value with the negative 5. And there's my y value. So that's what I have so far. So now I'm going to simplify this. So I get negative 5 equals negative 2 times negative 4 is positive 8 plus b. So I'm going to subtract the 8 from the other side, and we get negative 13 is b. So that b is my y-intercept. So now I just go and write my equation. Y equals m, which is negative 2, x plus b would be minus 13. So that would be the equation of the parallel line right there. I'll let you copy that down before I do the perpendicular line, because I'm going to erase that I just did except for the line. Okay, so now that you got that work down, remember you can always pause this. I'm going to erase these up here because I need that space to do the other line. And the other line, which is going to have a slope of 1/2, is the perpendicular line. And I'm going to go ahead and use y minus y1. That's our point slope form. Okay, and then I'm going to plug in my slope, which is 1/2 this time. I'm going to plug in my negative 4 and my negative 5. So negative 4. Now, when I plug in a negative 4, that's a minus a negative 4. So isn't that going to be a plus 4? Let's just go ahead and make that a plus 4. And when I plug in a minus 5 right here, isn't that going to end up a minus a negative 5? So that's going to be a plus 5 right there. Okay? Everybody got that so far? So far, so good. Okay, so now when I distribute, I get 1/2 x plus 2 is equal to y plus 5. But when I subtract the 5 from both sides, minus 5 and minus 5, I'm going to go down here because this is where I'm supposed to write my perpendicular. Y equals, the 5's cancel. Okay, and then I've got a positive 1/2 x minus 3. Okay, now would you agree that those two lines, first of all, they have negative reciprocal slopes, so they are perpendicular. But if I plug in negative 4, negative 5, right here, negative 4, negative 5, do I make my equation true? Okay, I get 8 take away 13 is a negative 5. So the point goes into this equation. But when I do the same thing over here, negative 4, negative 5, okay, I plug in the negative 4, I get a negative 2, take away a 3 is a negative 5, and they both check. Okay, so there's your board if you want to take notes from that. And I will come back with some more problems shortly.